Hello, welcome. FLI here once again, coming your way with information security course. This is a third year course being taught in the Computer Science and Engineering Department of the University of Mines and Technology. So I'm going to be the course instructor for this course, which is information security. Forgive me for my voice, I have a little sore throat. I'm hoping the recording will come out better and you will be able to hear me out. Now, the overall objective for the course is what is stated in the outline in here. So at the end of this course itself, students will be able to explain the objectives of information security, what it is, what goes into it. And of course, they will be able to also explain the essence and some application of each of these CIA triad or AIC triad, which I normally term as the confidentiality, integrity, authentication, and also availability. Students will be able to understand various cryptographic algorithms and the basic categories of threats to computers and also to the network as a whole. You will also be able to describe public key crypto systems and enhancements which are made by the IP version 4 using IPsec, so the Internet Protocol version 4. And you will be able to understand what intrusion and intrusion detection system is and discuss some fundamental idea of public key cryptography. Last but not least, we will delve into how to generate and also distribute a PGP key pair and use this package to send and also encrypt some email messages. Finally, we will discuss how web security and also firewall works, and we will hold a practical section of which I will give you some tutorials on how to use create firewalls for your homes and also organization. So the course presentation will be outlined just like what is being shown for other courses. So we'll have lectures which will be on VLE. So virtually each and every week I'll be loading videos online for you to go through, and there might be assignments in the videos. So I will entreat all of you to go through the videos and watch them and complete the assignments that I give in the videos. We will hold some tutorial section together with some practical session in the lab. For the lab session, there are some few things that I might want you to do before I'm ahead of time before we come to the lab to start some of the practical session. Now, I'm going to give you a handout, which will involve the PowerPoint slides which I'm using to teach you. So virtually all assignments and things that I will do, with the exception of personal presentation or group presentation, will be done on the VLE. This is going to be the lecture periods. So on Wednesdays and Thursdays, those are the lab session for the software, which we will hold at the software lab. And I will try to load the videos ahead of time so that you can view it before we have our practical session. So as I said, all assignments will be loaded on the VLE, and there will not be room for late submission. You get a 0 because if I give an assignment on the VLE and the time elapses and you are unable to submit it, it wouldn't be my fault. The system will go off on its own as has been set. Now, ways you can reach me in third years, I believe you already have my contacts, and those that are interested to probably work with me for your final year project, we can start talking since we are in the second semester, ahead of time to get ourselves ready. These are my research areas. At the moment, there is no TA, but I have spotted one individual who might be helping out. He's supposed to get back to me in the course of the week, so I will introduce you to him when that aspect is finalized. As you already know, the attendance is 10 marks. So the attendance, I am going to base it on the assignment that I'll give and the practical section that we will hold in class. So our advice, you do come so you don't lose any of the mark for the 10 marks. Continuous assessment, just like the individual project, MCQs and lab practical quiz, we'll hold some of them. The end of exam will be in the form of MCQs, fillings, and possibly a little practical. As in the course of the semester, I'll let you know what will happen before you write the exam. You know the pass mark is 50, and there are some policies that you need to adhere to when you are given assignments. Make sure you don't copy online and post it there for me. Some of the written assignment that I'll give you will be run through, turn it in, so you also get to see your percentage. And I expect that students will have a maximum of less than 20%. So I expect students to have about 19% in the written assignment that I'll give you. All right, so all these policies you already know. Now, for the practical session, these are the things that the software that we will be using to perform some basic firewall configuration. Yes, I would advise you would start, you look online and look out for Oracle VM virtual machine. So the virtual machine, as most of you already know, what it does, it gives you the chance to create a virtual computer on your physical computer. So you can have 2 or 3 or more computers using part of the resources that your physical computer has. So I would advise you look online, you download the Oracle VM virtual machine or the virtual box, and you install it. There are other firewalls that we would use in our practical session, and one is the pfSense firewall. We have SenseNet and the rest, and I'm sure we might take either pfSense or SenseNet, or we might use both in doing some basic configuration and in the practical aspect. And of course, we would also have some basic network monitoring tools that you can use to also analyze and sniff packets online to see what is going on. An example of such, an example of such network monitoring tool is the Wireshark. We can have Nmap and Top. In fact, there are lots of them. So I will introduce most of it to you, so you have a fair idea of how things work behind the scene when you browse or you're on a network. So I believe in this course will be a little exciting. Yes, so this, as I've said, will be the outline. So the 6 main topics that I'm going to talk in here will be centered on the attacks on computers and also computer security. That is going to be the chapter 1. We'll delve into cryptography. We'll talk about the concepts and also the techniques. That will be for chapter 2. We'll delve into symmetric key cipher. I might fuse some or incorporate some new topics within it, depending on how students understand and how the course will also go. There might be some few things that I might add. And of course, on the 4th chapter, we will talk about message authentication algorithm and how to use hash functions to help secure most of the messages that we send across on the network. And we'll delve into email security and also web security. Now, without wasting much time, let me just move straight into chapter 1, which we're going to talk about attacks on computers and also computer security. Now, these are the outline that we're going to go into with chapter 1. I'll start with introduction and end at the model for network security. Yes. So, as we all know, we are in a technological era where almost all our electronic devices are connected to the network. be it the local area network or maybe the wide area network. In some cases, it goes beyond to the internet. So this course would try to make such devices prone to activities like hacking, um, viruses, electronic fraud, and some few other things. So unless we have some security measures that we'll have to take, a network conversation or distributed application can be compromised so easily. So there are some examples of such, applications that can easily be compromised. The first one is what we have as the online purchases using the credit card or debit card. People use social engineering, to get some information of people online and use their credit cards to do some few other things. And of course, behind the scene, there are other things that go on in the dark web where people do sell credit cards of people, steal credit cards of people, and sell it out cheaply to other people, to do some transaction. Of course, another example would be a customer unknowingly being directed to a false website. We call such websites or such an activity as phishing, which is Phishing, phishing. So where an attacker probably will set up a rogue website which looks exactly like maybe a legitimate website just to steal information from people. So an example could be you can get an email that says your password is getting maybe compromised in a way, so click here to get your Facebook password corrected or something, and you are directed to a website which looks very similar to the login page of Facebook where you can enter your password. So this time round, the attacker, when you enter your new password or your old request for the old password and you enter it, the attacker then sniff or take in this password and now know your password and now redirect you to the website, the original website for you to log in. By the time you realize the attacker has access to your Facebook, it could also be a rogue website, which is maybe an e-commerce website where somebody will also send you maybe a website like maybe Amazon, which an attacker can send you a link which will take you to a website that looks so much like Amazon. And the idea is to steal personal information from you and use those personal information to impersonate you and do other things online. An attacker sending a message to a person pretending to be someone else. Yes, of course. There are ways to do some of these. I'm sure we'll get into how to do some of these practical session. We'll delve into some of these. Now, when we talk of network security, there are other things that come into play. So, network security itself has been affected by two major developments over the past decades. The first one is the introduction of computers in organizations. The moment computers came into an organization, we need to find a way to get all these computers linked together. That is where we have a network. And of course, the second one being the introduction of distributed systems, where we have an application situated on one server that needs to be replicated on another server. So these servers in turn comes together and form a distributed system. And the use of network and also communication facilities for carrying data between user and also computers. So the network security over the last decade has been affected by these two major developments: the introduction of computer into organization, and also the introduction of distributed systems, and the use of network and also communication facilities. So these two developments leads to what we term as the computer security and also network security, where computer security mainly deals with the collection of tools which are designed to protect and also halt or thwart the activities of hackers. So that is about computer security. When we talk of network security, too, these are the measures um, that we take to be able to protect data during transmission. But you should keep in mind that it is the information and also our ability to access the information that we are really trying to protect, and not the computer or the network itself. So the information that we have that we would want to access, they are the ones that we are really interested in protecting, and not the physical computer that we see or the network that we have already set up. All right. Now, because there are always threats to the information that we store on such electronic devices on the network, there is nothing we can do about it. We always would have hackers trying to find ways to steal such information. So there is always threat. And what is a threat if we still talk about threat in information security? So generally when you say a threat, when you talk of threat, it is either an object, person, or other activities that represent a constant danger, maybe to some sort of asset. So somewhere in 2007, the Computer Security Institute conducted some survey um, where these findings, emanated from the survey. Now, this is more or less a 12-year survey. It has been in existence for 12 years as until 2007. So in 2007, it was 12 years. This survey were being carried on virtually every year by the Computer Security Institute. It started somewhere in the 1996. Sorry. So in previous years, the survey was titled the Computer Security Institute slash FBI, Federal Bureau is it Intelligence? Yes. Pardon me on that if I made a mistake. So these two organizations, CSI and also FBI, were the ones that were conducting this survey. Although the people in the bureau, along the line, they wanted to be opted out, but behind the scene, they also gave um, they didn't really discontinue with it, but they were still also supporting to come out with this survey. And they believe the name FBI should be omitted from the survey. So now it is the CSI survey. And it's now being entirely administered by the CSI. So FBI is not really in there. But of course, if they need some sort of information, they are provided with it. So in this particular survey, which was conducted in 2007, these were the findings. They realized that about 494 computer security practitioners in the US corporations, and also the government agency and also financial institution. These were the people that got themselves involved, were more or less like the respondents to the survey. So they had 494 computer practitioners, getting involved in the survey. And they realized that, of course, we had also medical institutions, also university, also contributing to this. And out of this number, which is the 494, about 446% suffered some sort of security incidents in their organization or corporation or agency or company or institution. And out of the same number that suffered, about 29%, out of the same number, which was the 46% that suffered security incidents, 29% of them reported to the law enforcement. So of course, about 71 of them did not, of the 46% did not report to the law enforcement. So averagely, in a year, there was a huge loss of $350,424 that were lost from activities of the hackers. So almost 1/5, which is 18% of those respondents who suffered one of the or more kind of security incidents, further said that they had also suffered from targeted attacks, which is defined as the malware attack, which aimed exclusively at their organization and also at organizations within small subsets of the general population. So you can see how such institutions, were targeted just to steal information and also steal money and the rest. So the financial fraud overtook virus attack in this particular survey as the source of the greatest financial loss. So in previous years, financial fraud, virus attack was the main, financial loss, but this time around, financial fraud, with people using social engineering and the rest to steal money from people, where Citizen Coffee will say, Sister Neo, those kind of adverts that we see where we steal money from mobile money and the rest. But this time around, it was not virus attack, but it was financial fraud. So virus losses, which had been the leading cause of loss of virtually for about 7 straight years, now fell in the hands of financial fraud. So if separate category concerned with the loss of customer and also proprietary data, they are all lumped together. You realize that the combined category would be the second worst cause of financial loss. They also realized that another significant cause of loss was system penetration by outsiders. Of course, they also had insider abuse of the network access or emails, such as trafficking in pornography or pirated software. Anytime you visit a pornographic website and you don't have a good antivirus on your computer, please, you should be mindful because you'll become vulnerable for these attackers to dump viruses and also worms onto your computer. So please be mindful where you download even movies from. There are certain files that are also downloaded onto your computer without your knowledge. So you should be careful about all of these. You realize that sometimes when you are downloading a movie from a pirated website, you click on the movie to download, there is a pop-up. They use iframes to come out with all these pop-ups. So each of these iframes are being executed. When it's executed, they put some files on your computer. So if you don't have an antivirus, it's unable to track them. By the time you realize, you have become vulnerable. So inside abuse of network access or emails edge out virus incidents as the most prevalent security problems, with about 59 also 52% of respondents reporting each of these respectively. So this is a picture of the dollar amount losses by type of attack that occurred in the 2007. So in total, about 66,930,950 US dollars were lost to all these kinds of attack. So you can imagine how much, within a year, this is how much they lost. The financial fraud, as I said, was the highest per the CSI survey, and that was around 21,124,750. Of course, virus, also worms and also spyware were able to also steal some important information from organizations and institutions. So it goes down, each of these attacks they keep going down, letting us know how much was lost. And of course, the last was the exploit of organization DNS server, which was just 104,500, which is huge money when converted to Ghana cedis. So that is a picture of what's really happened in 2007. Of course, now there are sophisticated ways of even doing some of these attacks, and day in, day out, huge sums of money are being lost. The banks will not tell you, but you realize that. Sorry. Sorry. The banks will not tell you, but if they should come out to let you know that they are vulnerable to some of these attacks, I'm sure you'll find difficulty in saving your money online, saving your money in the bank. But of course, because they are saving it for you, they have no options than to, even if it's being stolen, even if it's stolen, they have to find ways of letting you have your money back if you do request for them. So why do we need information security? We've gone through some other reasons why we need it. So why we need information security? We talk about threats, and there are other categories of threats that also emanate when we talk about information security. So the threat categories, as you can see, we have an act of human error or failure. Of course, these are all ways that poses threats to an organization. There are times humans do make errors, maybe in their application that they develop. If we're supposed to do some computation and there is a mistake, some monies are added to some people's money and the rest. These are other threat that needs to find ways to mitigate. Compromises. So the threats that we spoke about, they can be categorized in this way. So compromises to intellectual property, deliberate act of espionage or trespasses. When we talk about deliberate acts, we have an example as espionage or trespasses, spies, having spies to steal information extortion, deliberate act of sabotage, or also vandalism. And of course, deliberate act of theft. In the area of deliberate software attacks, hackers can write scripts, attack specific software just to steal some important information. Forces of nature, those ones, there are times we can't really deal with it. Deviation in quality of service. We also have a category as a technical, which falls in a hardware failure or errors, and also software failure or errors. And the technological obsolete. If your technology is quite obsolete, it makes it vulnerable for hackers to get into it, because there are new technologies and there are new ways of circumventing old technologies. An example is if you have your phone and you put up your hotspots for people to connect, and the technology that you use for the hotspots is probably WEP, which is Wired Equivalent Privacy. That is the encryption that you use to secure your wireless. Then you are very vulnerable, because there are ways to hack a WEP with a Wired Equivalent Privacy wireless. It is so easy. I can just sit here within a matter of 10 seconds or 15 seconds. I will have the password that you have on your wireless access point, or maybe your hotspot, and delve into your phone and do certain things with it. That is why the technology has been in such a way that I think by default it selects WPA2 We have WPA and WPA2, which is an advance of the WPA. So when you hotspot, put up your hotspot and you check the encryption that the hotspot is giving out, you see that it is WPA or WPH2, the other ones that are available. As I said, this information security is quite broad, so we will go step by step and do some few things in a practical session. All right, so the threats can be categorized into the ones that I've listed in here. Now let's give a brief some definitions that I would want you to look at. Computer security, network security, and also internet security, as you can see. I have a short assignment for you, which I would want you to do. I'll put up the assignment on the VLA, and what I would want you to do is, what I would want you to do is to give a brief description of the differences between the following: computer security, network security, internet security, information security, and cyber security. I'll put it up on the VLE and I'll give a deadline to it. So make sure you go online, you read, understand, and write on your own the differences between these. If some are subsets of the others, let us know in your write-up. Please don't copy things online and just dump it for me. I'm going to receive this in a 1018 assignment. So I will know the percentage that is coming. If the percentage is more than 20, I will not even read it and give a score of 0. I read things that are below 20. So please be mindful when you put up or upload and get some information online. Now, when you talk of computer security, it is generally a name for the collection of tools designed to protect data and also halt, as I've said, or thwart hackers. So whenever we have a collection of design tools to protect data and also stop the activities of hackers, that is the computer security. Network security are measures that we put in place to protect data during their transmission. So the measures that we put in place to protect the data that we are sending from one computer to the other over the network during the transmission period, that is the network security. And of course, the internet security are the measures we put in place to protect data during their transmission over a collection of connected networks. So we have a network security in the general definition. We have a network in UBAT. If we have another, like a Chicago campus, we can, because they might be connected over the wide area network, we can, in a way, term this as maybe internet security, because there are two different networks. Of course, when you have so many networks coming together, that is what serves as the internet. But you should be mindful that our main focus is on internet security, which consists of the measures that we put in place to deter, to prevent, to correct security violation, and to detect that involve the transmission and also the storage of information. Now, from the diagram, as you see here, over time you can see that the attacks on the internet and also the internet attached systems have grown more sophisticated. You know, the attacks on the internet and also the internet attached systems have become so sophisticated, while the amount of skills and knowledge which is required to mount such an attack has declined. So in the olden time, somewhere in the 90s, you know, for a hacker to be able to, you know, steal or attack a system, they need to have very good knowledge of network security and other things to be able to attack a system. But this time round, those times they do a lot of command prompts, activities to attack these systems. But this time round, we have graphical user interfaces, okay, and more sophisticated applications that can help us, perform the same action without having to know rigorously or in depth, have full knowledge of some of the things that will go into to do these attacks. So we have graphical user interface that are interfaced on the command line to perform some of these attacks. So attacks have become more automated and can cause greater amount of damage, using these sophisticated, tools that are available. We will use some of the tools in the course of the semester. Now, in terms of the aspect of security, the X800 data security architecture itself, for the Open System Interconnect, which is the OSI model, I'm believing that in first year you know what OSI model is. Open System Interconnect, where we have all the 7 levels, and I'm sure you are familiar with the acronym. Please do not throw sausage pizza away. Please do not throw sausage pizza away. The physical layer, the data link layer, um, do not, the network layer, session, the application layer, all these 7 layers, which is the Open System Interconnect model. I'm believing you know all of this. So the X800 data security architecture of the OSI model is given by the international, which is the ITUT, which is the International Telecommunication Union, telecommunication standard sector itself. They do recommend the X800 model. So the X800 is a security architecture for the OSI model. So when we talk about the security architecture for the OSI model, where we have all these layers in there, we are talking about the X800. When we do the wireless signals that we have runs on IEEE 802.11 protocol. So each of these security, there are lots of security architectures that are available, but the ITUT recommends the X800 OSI model for as a security architecture for the OSI model. So you already know also that the OSI model is a reference model. I believe I gave this assignment to you in first year. Yeah. Yes. And of course, the X800, it defines a systematic way of defining and also providing security requirements. So there are 3 main aspects of security in the X800 model that you always have to consider anytime we think of information security. And these are the ones that have been outlined here. We have the security attack, the security mechanism used for the attack itself, and also the security services. We are going to talk about each one of them. You should be mindful that the X800 defines, as I said, a systematic way of defining and also providing security requirements. And it does that using these 3 main aspects of security for each model. Whenever we think of information security, these are the 3 main aspects of X800 that you should have in mind. Now let's talk about the first one, which is the security attack. So security attack itself, so anytime we have an intelligent action or any deliberate action that compromises the security of information owned by an organization, then we are talking about security attack. So information security in itself is about how to prevent and also detect attacks on information-based system, any system that contains information. So information security is about how to prevent and also detect attacks on such systems. So usually threats and also attacks are used synonymously. We use it interchangeably to mean virtually the same thing. So when I talk about threats and when I say attack to I'm really talking about the same thing. So these have a wide range of attacks. There are lots of attacks that are involved when we talk about security attacks. We'll talk about almost all of them. Now, security attacks can be focused of generic types. There are two main types of security. Virtually all the attacks that that occur fall within these two main could be in these two main types. It could be what we call passive, and it could also be active. I'm talking about security attack could be in the form of passive, it could be in the form of active. There are a lot of security attacks that are available. And we can do these attacks in a way that could be passive or maybe active. When we talk about passive attack, what do we really mean? Let's look at the diagram as you see. When we talk about passive attack, there are attacks where the attacker, let me bring out this. Passive attack are the attacks where the attacker itself indulge in unauthorized eavesdropping. By eavesdropping, the attacker sniffs information on the network. They have access to the network. They're able to sniff information from the network. And what they do is they just monitor the transmission or gather information. And these eavesdroppers do not make any changes to the data or the system. So let's take this individual. We have Bob here. He wants to send an email to Alice over a connection medium, which is the internet or any other communication facility that is available. So he sends the information. During the transmission period, we have this individual called that. What he does is he's able to tap into the message that Bob has sent because he's also on the same internet or also communication facility. He's able to tap into, by tapping into, I mean to say to sniff or to eavesdrop that information sent by Bob. And what he does is his own main concern is to read the content of the message from Bob to Alice. That is what he does. He doesn't do anything to it. So by reading it, he can analyze and do other things. So of course, when we have an attack in the form of passive attack, it's always very difficult to know what is happening. So, and the reason is in the passive attack, the attacker does not really do anything to the data that is being sent to the recipient. So the recipient or the network administrator has no idea and information that needs to be sent has been compromised in one way or the other because he's just viewing the information and making some sort of inferences from that information. He doesn't do anything to that information. So that is a passive attack. That is very dangerous. So we have some people who are just observers on WhatsApp group page. They are just looking and smiling behind the scene. They are just reading. So if you are in a WhatsApp group and you are smiling and reading information, you are more or less like you are conducting a passive attack. Please, I'm using this one as in actual fact, that is not how it is, but I'm using this one as an analogy to help explain what a passive is. Now, so that is what the passive does. The passive attack is. So you read, you do it, you use it for other things, but you don't change the data that is being sent from the sender to the recipient. So unlike active attack, passive attack is hard to detect, as I've said, because it doesn't involve any alteration in the data or system resource. So that's the attack entity does not get any clue about the attack. So it's always very difficult, to detect and also prevent such attacks. Although we can find ways to prevent it using, encryption method, where the data is firstly encrypted in an unintelligent, language at the sender's end. So in that case, we can mitigate this particular problem. Before the message is sent, we can encrypt it and give the encryption key, an encryption key to Alice. So the information which is Kofi is a boy has been encrypted into some numbers or something. So he will not be able to understand what the message is, even if he intercepts it or he eavesdrops it on it. Alice will also see the same information, which is numbers and the rest, but because she has the key to the information, is able to decrypt that information and now view the actual information. That does not have the information, the key, so will not be able to decrypt the information and use it for his or her own personal gain. All right, so by the time it gets here, the information can be read by Alice. So this is also it's the same example. We have the sender sending a message to the receiver, and we have an attacker observing just the message. All right, so let's talk about the active attack. This is how the active attack looks like. It's a little more active because the attacker is more or less involved in what is happening. So in the same analogy, if you are viewing information on a WhatsApp group page, whoever sends information reads it, and assuming there are lots of talks, somebody can tweak the statement that you said in previous messages into a way that will make you seem bad, especially if you want to, cause commotion or havoc on the page. So those that are really smart would want to go back again and retrieve the original information. So for an active attack, Bob sends the information through the internet or the communication facility, and that rather does not send the information. What he does is he picks the information, alters the information, and now sends to Alice. So he captures the information from Bob to Alice, later replies the message to Alice. So Alice will not be able to know the exact information that was sent. Or what that can also do is to still forward the information to Alice, but this time round, he will have access to Bob information and now send different set of information to Alice, making Alice feel that it was Bob that sends those information to her. So that is the active attack. So these are attacks in which the attacker tries to modify the information or create a false message to the recipient. Well, the prevention of these attacks is quite difficult because I'm talking about this type of attack, is quite difficult because of a broad range of potential physical and also network and software vulnerabilities. So those of us who, in fact, I think I'm also culpable, who download software online and crack it, please, we are all vulnerable. And like Microsoft Word, for instance, we never buy Microsoft Word, right? But what we do is we always download it and we crack it and we use it. An attacker who is very versed in, seeing the loophole in such cracked software can come into your computer whenever you're online and also steal some information from you. So I would always advise students to just use about 100 cedis or 50 cedis of your pocket money to buy an antivirus, a very good one. I am using Kaspersky. I'm not campaigning for them anyway, but there are other good antivirus that are available. In this part of the world, I will always advise you have an antivirus installed on your computer, because in fact, we use pirated software a lot because you're unable to purchase them. So our advice, in a year, if you spend 50, 60, or 70 cedis to buy an antivirus, it's a good thing. So please, when you are buying a laptop, add antivirus to it. I'm sure your parents will want to buy one for you. Even if it is 120, it's more or less like 10 cedis in a month. If you save 10 cedis for each month for 12 months, you can buy an antivirus. All right. So that's a way of protecting yourself. So as I said, the prevention of these attacks is quite difficult because of a broad range of potential physical and also network and software vulnerabilities. Right? network, we don't know where the attacker is coming from and eavesdropping, so it becomes difficult to trace unless certain measures have been put in place on the network to detect the IP addresses of each of the attacker. And of course, we also don't know the software that is so vulnerable that the attacker is using to intercept and sniff data or information from the user. So instead of the prevention, it emphasizes on the detection of the attack and also the recovery from any disruption or delay caused by it. So the major difference between the active and the passive attack is that in active attack, the attacker intercepts the connection and modifies the information. Whereas in passive attack, the attacker intercepts the transit information with the intention of reading and also analyzing the information, not for altering it. So that is the difference between the passive attack. And I said so many attacks could happen, but it could fall within these two categories. Now, an example of the security attack, let's talk about the first one, which is the interruption. So when we talk of interruption, it's any asset or an asset of the system is destroyed or become available or unusable. It is an attack of availability. So if you have an asset of a system which is destroyed or become unavailable or unusable, this type of attack falls under the interruption category. So there are times you're trying to access a site, possibly like the VLA, for instance. We can have a denial of service attack. We are trying to access it, and somebody behind the scene is conducting a denial of service attack on the network. And please, when we do some of these tests in class, please don't use it on the network. Let us treat some of these in a way that would be more for education, but not to compromise an institution's network. And you should be mindful that it is illegal by law. It is wrong for an attacker or a hacker, be it educational hacker or for educational purposes or not, to use hacking tools to, disrupt an organization architecture. It is illegal. When you are caught, you could be prosecuted. So please have that in mind. That is why anytime people take cybersecurity courses, they set up labs within their computer or a designated network for them to perform these attacks on. So some example of interruption can also be the destruction of some hardware, the jamming of wireless signals. There are devices that you can use to jam the wireless signals that are available within a specific location. And this would prevent people that want to get access to the network. People will not be able to connect to the network. We have a lot of them available. And also disabling the file management system. These are examples of interruption. And as I said, this type of attack is a vulnerability, it's an availability attack. Before, I talked about the CIA or the AIC triad. I think I will talk about it. So A in that sense is the availability, making it available for people to have access to. Okay, so let me talk about the next one, which is the interception. So an unauthorized party tries to gain access to an asset. So this is a confidentiality attack. So when you have an unauthorized individual who gains access to an asset which is not supposed to have access, it's a breach of confidentiality. So example are these three: tapping to capture network data in a network. So you are not supposed to have access to some asset, but because you are able to intercept such information, it falls within a confidentiality attack. Illicit copying data or programs. You are not supposed to have access to all of this, and also eavesdropping. There are those times um, the landlines that are available in homes. You connect from a pole, you take it to your home, you connect to the home telephone. Anybody? I remember those times I witnessed somebody who the cable that came from the pole, he tapped into it and he had his own what do you call it, telephone. So he cut some portions of the cable, then he connected it to his telephone in his room. So if a call comes to that line, the legitimate person who is supposed to receive it will hear the call. It will ring at its end, and the illegitimate person will also hear, you know, the sound of the call. So can eavesdrop. What happens is with the legitimate person pick up the phone and is talking on the phone, this illegitimate person is able to eavesdrop and listen to all the conversations that happens. And again, when the legitimate person is not around, because it's already tapped into the original wire, it's able to make calls for free. And at the end of the day, who bears the cost is the legitimate person. Because he is unknown, he doesn't know what is happening. Yes, so this is more of an interception or an attack on confidentiality. Modification also falls on integrity. When an authorized party gains access and also tampers with the asset of what he is, of which he has been able to gain access to. An example of such is the changing of data files and also altering a program or the content of a message. So that is about modification. Fabrication, also when an unauthorized party inserts a counterfeit object into a system. Attack on authenticity, also known as impersonation. So the software that we have been using to, the pirated software that we crack, we don't really have access, we are fabricating on it. We insert some sort of counterfeit objects into the software itself. So this falls under authentication. We are not really authorized to authenticate with such applications, but we are impersonating and doing things and making it possible for us to use that such system. And these are the examples that are available. The hackers gaining access to a personal email and also sending messages. That is why we always try that whenever you create a password, have some hashtags and alphanumeric, should have contain some letters, should contain some characters and also some numbers. And you should be changing your password day in, day out. In fact, some of these vulnerabilities, we are all prone to it. We sometimes use passwords for years and do not make any change. I will not be surprised if a student has access to my email address, credentials. Anyway, please, if you do, don't be a passive attacker, but please don't be a passive attacker. I'm not saying be an active one. Behind the scene, just hit me up and let me know. All right, insertion of records in data, insertion of spurious, that is intended to deceive. When we have ways we intend to deceive by sending some messages in a network. So these are examples of fabrication, inserting counterfeit objects into it. Now, the security threats that we've all talked about, all these four security threats can be represented as you see over here. So for a normal flow, ideally, we have the information at the source being sent directly to the information to the destination. So the destination individual gets the actual information, which is the normal flow. When there is an interruption, of course, the message that is supposed to send does not reach the recipient. When there is a modification, the message goes into the attacker's platform. He modifies it before he sends it to the recipients. If we have an interception, the message goes to the recipient. However, it's being intercepted by an individual, an attacker or adversary. And finally, for fabrication, the message does not even move from the sender, but we fabricate an information from the attacker's end, and it sends it onto through the network to the recipients. So all these attacks can be represented graphically as I've shown in here. Now let's move on to the security services. I told you from previous slides that let me bring out that particular slide. I told you from previous slides that sorry. Just a minute. Yes, so that there are three aspects of information security that we always have to consider for the X800 model, and these are the three: security attacks, security mechanism, and security service. So now let's move on to security service before I talk about security mechanism. We've dealt with security attacks, so let's talk about security service. This is what we talked about in the previous slide. All right, so for security services, it is a communication service or a processing service that is provided by a system to give a specific kind of production to systems resources. So anytime we have a communication service or a processing service that is provided by a system to give specific kind of production to a system resource, we term it as security service. Now, security services are meant to implement security policies and are implemented by security mechanisms. So we have lots of services that are available, and these services, before they can work, they have to be implemented by security policies. And these security policies are being implemented by security mechanisms. We'll talk about each one of them. Now, so based on the attacks, we will need to find a way to identify which security service can remediate the attack. So there are virtually about 6 security services that are available that we can talk about here. And these include the confidentiality, the authentication, integrity, non-repudiation, access control, and also availability. Amongst these 6 security services, there are 3 of them key. The 3 of these services that are so key when we talk about information security. So for a system to be called secured, it should be able to meet up with these 3 triads, which we term as the AIC triads, which is the authentication, integrity, and confidentiality. So it is sometimes also referred to as the AIC triad, and other times too it refers to as the CIA triads. CIA is the same abbreviation, but because CIA is known in the US, and we don't want to conflict with it. That's why we also an individual Elster, I think somewhere in 2015 or so, coined these into an AIC triad to make it easier. So these 3 security services are very key when we talk about computer security or information security. But of course, there are 6 of them, but these 3 are very key. Now, let's talk about confidentiality. So the idea is being able to hide information from unauthorized users or individuals is termed as confidentiality. Well, there are certain things more like our privacy. So if we're able to hide it from other people, this is the confidential, something that is confidential to us. So anytime we are able to hide information from unauthorized access or individuals or users, we term it as confidentiality. So confidentiality is the most apparent aspect of the AIC triad, and also the most attacked among the triad when it comes to information security. Yeah. Anytime you hear of an attack and an attack and an attack, most of the attacks, you know, falls under this security service, which is the confidentiality. So encryption and also cryptography are used to ensure the confidentiality of data transfer among network devices. So to remediate or to mitigate this issue, we have to find a way to encrypt the data that we have that we don't want or we want to hide that we don't want other people to see that we are hiding from them. We have to find a way to encrypt or maybe use cryptographic analysis or some sort of algorithm to encrypt such data. Confidentiality is also the protection of data transmitted data from passive attack. So it's normally used to prevent the disclosure of information to unauthorized individuals or system. It can also be defined as ensuring the information is accessible only to those authorized to have access. So, by the explanation I've given, I just give you a recap of some of the things. So, most of the time, the other aspect of the confidentiality itself is the protection of the traffic flow from analysis. Being able to protect the traffic or the data that passes through a communication medium. Now, a typical example of such attack or service, security service for confidentiality attack is a credit card number that is being secured during an online transaction. So, of course, the numbers that we put in to purchase things from online needs to be secured in such a way that attackers will not be able to steal such numbers and also use it to conduct other transactions on different sites. And mind you, the good thing is most of the banks also provide something we call V by V for our credit cards or debit cards. We call it V by V, which means verified by Visa. So in that case, whenever you are making a purchase online, you'll be requested to enter your phone number as a third party authentication or a third level authentication. You enter your phone number, and if the phone number tallies with what the institution or the banking institution has, they send you a code which you use to complete the transaction that you started on the e-commerce website. It could be an email or maybe a phone number where the text message is being sent. Okay, so now the next one, which is the authentication. This service actually assures that the communication is authentic. So for a single message transmission, its function is to ensure that the recipient assure the recipient that the message is from the intended source. So looking at this type of attack from here, fabrication, you can see the information was not sent by the recipient. So authentication, what it does is its function is to assure the recipient that the message is from the intended person. So for an ongoing interaction between two aspects, these are what goes on in there. So firstly, during the connection initiation, the service ensures that the authenticity of both parties. So you want to send an information to this person. What the service does is to find out if these parties are linked in one way or the other to be able to, for the transaction to go on. Secondly, the connection between the two hosts is not interfered allowing a third party to masquerade as one of the two parties. So authentication assures the communication is authentic for both parties, be the sender and also the recipient. Now we have another one, which is the still under authentication. Two aspects of authentication services is defined with the X80, X800 model. Just a minute. Sorry. Yeah, so two specific authentication services are defined by the X800 model. And the first one is the peer entity authentication, the second is the data original authentication. Now, for the peer entity authentication by the X800 model of the OSI reference model, what it does is it verifies the identity of the peer entity involved in the communication. And it also provides use at a time of connection, establishment, and also during data transmission. And finally, it provides confidence against a masquerade or an attacker or an adversary or a replay of attack. So that's a peer authentication, entity authentication. Now for data original authentication, what it normally happens is it assumes the authenticity of the source of data. Where is the data coming from? But does not provide protection against duplication or modification of the data unit itself. When what it does is it supports applications like the electronic mail, where no prior interaction takes place between the communicating entities. So these are the two specific authentication services that is being provided by the X800 when it comes to authentication of the authentication service, security service. The next one is integrity, which is the third of the triad, which is integrity. When we say integrity, what it means is that data cannot be modified without an authorization or unauthorized access. So what integrity does is it protects data or information from improper modification and also destruction. And it does this by ensuring information non-repudiation and also authentication. I'll talk about non-repudiation in the subsequent slides. So the non-repudiation generally, um, when a transaction goes on, is just a way to verify that this person is the one who is actually, completing some sort of transaction based on some services that needs to be provided. So, like confidentiality, it can also be applied to a stream of messages where a single message or sometimes selected fields within a message can be applied when I talk about the stream of messages. So an integrity service can be applied with or without recovery. We can apply it in such a way that we can recover or we can not recover. And because of this, it is related to active attack. The major concern will be the detection rather than prevention. So we have to find a way to detect it rather to prevent it. So I'm sure in the practical session we will touch some few nuts about these. So if a violation is detected most of the time, and the service reports it, either the human intervention or an automated recovery machine are carried out to do the recovery. Anytime such a violation is detected, this is what happens. You can have a human intervention, trying to do the recovery, or we can have an automated machine or script that has been written to cater for sex, detection to do a recovery on the system. So there are generally two types of integrity services that are available. And the first one is the connection-oriented integrity service, and also the connection-less oriented. So for connection-oriented, most of the time, for connection-oriented, most of the time what we are talking about is this service. Most of the time, it deals with a stream of message, assures that the messages are received. Let me put it this way. Let's use this one as an example. TCP and UDP, the difference between TCP and UDP are examples of connection oriented and also connectionless oriented. So let's talk about the first one, connection oriented integrity. So this service deals with a stream of messages, assures that messages are received as sent, with no duplication, no insertion, no modification, no reordering, or no rippling. It is responsible for that. That is the connection oriented. So in this case, the extraction of data is also covered here. And because of that, it tends to be to both message stream modification and denial of service. So because it assures that the messages that were sent are delivered and the same message is received by the recipient, denial of service attack usually will not really happen here. So in other words, we can also say that connection-oriented protocols or services makes a connection and also checks whether messages is received or not, and send again if there's an error. So for instance, if we are sending an email or we are trying to visit a website like the UMAT website, and we are saying UMAT because we are in UMAT, or maybe Facebook. If we are trying to visit Facebook, you type facebook.com in your web address, browser address, and it keeps loading and the network goes off. For a connection oriented protocol or integrity service, because the network went off, it will try to also reload again if the network comes back, so that the actual information that you're supposed to get will be displayed for you, which is facebook.com. So for connection-oriented integrity services or protocols, TCP usually are the ones that is protocol is the one that is normally being used. That is the transmission control protocol. It's meant for connection-oriented integrity services. For connection-less oriented security service, that is where UDP comes into play, like the user datagram protocol. So, for instance, if you are Skyping or streaming a video online and parts of the video is not really displayed well, maybe the mouth is not displayed well because the network was bad at that particular point, the mouth of the person speaking, you don't really care about the mouth really not happening, but because it's able to stream, we don't care that the eye did not display well, the mouth did not display well until the connection is reinstated. So just like Skype or even your what do you call it, WhatsApp call. If you are calling and there is some scramble in the network, you might not see the person very well and all of that. So this type of protocol is a connectionless oriented protocol, and it's a type of integrity service when it comes, we talk about security services. So it deals with individual messages regardless of larger context, providing protection against message modification only. Or a connectionless oriented protocol does not guarantee a message delivery. So it's not all there. Sorry? Excuse me. So if it's all the packets are not being able to display, it doesn't really matter. Um, Once the person is able to appreciate part of the message that is being said, it's more or less okay for them. So among these two connection-oriented services, the connection-oriented services is more reliable than the connectionless services. But of course, it's always best to use TCP to as a way of as the best protocol to conduct things that needs to be delivered. And the ones that you don't really care what happens, then we use connectionless services like the UDP. So let's take a short example to understand the difference more clearly. So let's suppose there are two houses, H1 and H2. And so these two houses are situated at two different places. And we have a letter that has to be sent from H1 to H2. Assuming there is some sort of river between these two houses, now how can we send the letter? So there are two ways. The first solution will be to create a bridge over the river and then it can be delivered. Excuse me. The second will be to get it delivered with maybe a pigeon, the pigeon bed. So when we consider the first solution as TCP, which is a connection-oriented service, the connection has to be made, and that connection is the bridge to be able to get the data, which is a letter, delivered. So in this case, the data is reliable because it will directly reach the other house, which is the other end, without loss in data or also the error itself, data or error. So because we build a bridge over the river, it is very easy to move from house 1 to house 2 to deliver the letter. On the other hand, which is the second solution, which uses UDP, that is the User Datagram Protocol, no connection is required for sending the data. So in this case, how is it done? So the process is fast. This type of process is fast as compared to the TCP. So this one gives you a comparison. For connection-oriented services, is a little slower compared to the connectionless. So the process is fast as compared to the TCP itself, where we need to set up a connection, which is a bridge. So we have to now go and create a bridge before we can send a letter from one point to the other. So that slows that process down. But the data is not reliable. UDP is fast, but the data to be transmitted is not reliable. We don't know whether the pigeon will be able to go in the right direction from house 1 to house 2, or it will drop the letter somewhere on the way, be it inside a river or somewhere far away from the house 2, which is H2, or some issue is encountered within the midway. So although the connectionless oriented protocols or services is fast, it's not really the best because we can't guarantee the transfer of message, whether it was delivered or it was not. So these are the differences between the connection oriented integrity services and also the connectionless oriented integrity service. So when you think of connection, TCP, connectionless, UDP. Now let's talk about, still on the security services, let's talk about the next one, which is the non-repudiation. When we say non-repudiation, it's the assurance that someone cannot deny the validity of something. So it is legal, this kind of service is a legal concept that is widely used in information security and refers to a service which provides proof of origin of data, the integrity of the data. So, in other words, we can say that non-repudiation makes it very difficult to successfully deny who or where a message came from, as well as the authenticity and integrity of that message. So if you let your friend use your laptop and your friend has a password to use your email to conduct some activity which is unlawful, because we have been able to track that it's your laptop and it's your IP and it's your email that were used to do all these unlawful activities, it becomes so difficult to deny that this was not really you, because your login credentials is supposed to be unique to you. You don't give it out to your boyfriend because you are in love, or you give it to your girlfriend because I'm in love, and all the rest. If something happens at the end of the day, it will be very difficult to prove that this is not you. So please be mindful of that. So that is where non-repudiation comes in. So non-repudiation makes it very difficult to successfully deny who or where message came from, as well as the authenticity and integrity of that message. So it's the assurance that somebody cannot deny the validity of something. So this capability is crucial to e-commerce. It's very important to e-commerce. So always e-commerce website always try to incorporate the non-repudiation service in the development of their system. So in e-commerce, so the digital signature combined with other measures can offer non-repudiation when it comes to online transaction. So in this case, it is crucial to ensure that a party to a contract or a communication can't deny the authenticity of their signature on a document or sending the communication in the first place. If I have your Visa card and I do a transaction in your name, and I have your V by V key and all of that, and I use it to pay for goods online, of course, the deduction will be made because all the key things that are supposed to be peculiar to you have been provided. So it makes it so difficult to say you didn't order for some kind of transaction online. So please keep your Visa cards or MasterCards, in safe places. Don't let it lie around. If somebody has, just see the 14 or 12, 16 digits code, you are doomed. If it sees your CVC, which is the code at the back, you are in trouble. So please, let's find ways to hide that. So in this context, non-repudiation refers to the ability to ensure that a party to a contract or a communication must accept the authenticity of their signature on the document or sending of a message. So without it, an individual can or entity can deny that he or she or it is responsible for a transaction, therefore not financially liable. So that is non-repudiation security service. Let's talk about the control service. Sorry, the access control. As the name says, access control. You should have access to be able to control. So this refers to the ability to control the level of access that individuals or entities have to work, would have to a network or a system, and how much information they can retrieve. So for instance, let me use the VLE as an example. The lecturers have access to be able to create courses and also create a Roman key and upload course materials and lecture materials because they have the access control to do all these. Now the students' access control limits them to create a course to invite students, other students into the class by creating enrollment keys and the rest. So each user of the system have something we call access control, which controls the level of access of such individuals on the system. So the administrator, for instance, will have the chance to create lectures, to create courses. So virtually everything that the administrator can, that the lecturer can do, the administrator can do and do more. So the lecturers becomes a subset of the administrator, whereas the student also becomes a subset of the lecturer. Because if you enroll in his course, he has a chance to give you some assignments and other activities for you to do. So the ability to control the level of access that individuals or entity have on a network or a system and how much information you can retrieve is the access control. So it's also the ability to limit the control that access, the access to host the system and applications via communication links. So every access group have things that they can do. Students can enroll into courses and take courses and activities. Lecturers can create, enroll, create enrollment key, create courses, as many courses as they want, and even enroll students into the class. Administrators can create lectures, can create courses, can enroll into class and do so many things. So based on the access level, there are other things that you can do. So for this, each entity trying to gain access must first be identified or authenticated so that access rights can be tailored to the individual. Still on security services, the last one was the availability that I'm going to talk about is the last component of the AIC triads, and it ensures timely and also reliable access to and use of information and also system resources. So in other words, availability guarantees that systems or applications and data are available to users when they need them. So if you're accessing a system and it's unavailable, it falls under the availability security service for the X800 model. So the most common attack that impacts availability is denial of service. So I'm sure you remember your writing exam and especially the first years, there was some sort of denial of service. Somebody was bombarding network with unnecessary traffic and the rest. And yeah, so when we talk about availability, the type of attack that is prone to such activity, such service is the denial of service. So as the name says, denial of service. So you deny an individual access to a service that is looking out for. So there are tools that you can use to conduct this denial of service attack on an information system or an application. And as I've already told you, it is illegal worldwide to conduct any kind of denial of service attack on an institution's application. When caught, you could be prosecuted. So please be careful. And as I said, we would do some basic stuff like this in the practical lab. All right. It is defined to be the property of a system or a system resource being accessible and also usable upon demand by the authorized system. So authentication and also encryption and others need some sort of physical action to prevent or recover from loss of availability. So we try to bring out ways to counter and block certain IPs or traffic that keeps jamming networks. Now let's talk about the mechanisms, the specific security mechanisms still under the X800 model. So a process, I'm talking about mechanism now, a process or a device incorporating such a process So there is have a process or a device which is incorporating such a process that is designed to detect, to prevent, or recover from a security attack. That is termed as a security mechanism. So according to the X800 model, the security mechanism can be divided into two. The first one is a specific security mechanism and also the pervasive security mechanism. When we talk of the specific security mechanism, these are those that are implemented in a specific protocol layer. So, so you deploy these security mechanisms in a specific protocol layer of the OSI reference model, which I've talked about. And also those that are not specific are the ones that are pervasive security mechanism. So those are not specific to any particular protocol layer or security service. Now the X800 also differentiates reversible and also irreversible encipherment mechanism. We'll talk about encipherment in subsequent lectures. So a reversible encipherment mechanism is simply an encryption algorithm that allows data to be encrypted and also subsequently decrypted. That is the reversible encipherment mechanism. You can encrypt the data. Excuse me. And at the end of the day, you can also decrypt that particular data. Sorry. So, however, on the other hand, or whereas the irreversible encipherment includes hash algorithms and also message authentication codes used in digital signature and also message authentication application. So we use hash algorithms in irreversible encipherment and encryption algorithms and the reversible encipherment. Now, still on the specific security mechanism, there are about 8, 1, 2, 3, 4, 5, 6, 7. There are about 8 specific security mechanisms, but as displayed here, most of the time, the other one, which is routing, is not really incorporated here, but we'll talk about it. So when we talk of the specific security mechanisms, there are about 8 of them. So the specific security mechanisms are incorporated into appropriate protocol layers in order to provide some sort of OSI security services. So the first one is the encipherment. The second is the digital signature. We'll talk about each one of them. When you talk of encipherment, this security mechanisms, well, it deals with hiding and covering of data, which helps data to become confidential. So, of course, we would encrypt such data. It is achieved by applying some sort of mathematical calculations or algorithms which reconstructs the information into not readable form. So that is encryption. It is achieved by two famous techniques named cryptography and encipherment or encryption. So the level of data encryption is dependent on the algorithm which is used for encipherment. So there are certain algorithms that can encrypt, just like how you will encrypt your password when you create a web application using maybe MD5 to encrypt your password. So based on the algorithm that you use, the level of the data encryption could be high or low. So that is about encipherment. So that's a mechanism that deals with hiding the data by using encryption. When we talk of digital signature, so this is also a security mechanism which is used by appending values to data. So you have data, you append values to set data to which is created by the data itself. So it is similar to sending packets or of information known to both sender and also receiving party and checked before and after data is received. So in this case, when this packet or data which is appended is checked and is the same while sending and receiving, data integrity will be maintained. So that is about digital signature. Let's move on to the next one. Access control, which we've talked about earlier, but I just want to talk about it in the context of security mechanism. So this mechanism is used to stop unattended access to data which you are sending. It can be achieved by various techniques such as applying passwords, using firewalls, or just by adding PIN to data. When we talk about data integrity as a security mechanism, this mechanism is used by appending values to the data to which is created by the data itself. It is similar to sending packets of information known to both sending and also receiving parties and checked before and after data is received. So they have some sort of key that they can use to check the integrity of the data that is sent. So when this packet or data which is appended is checked and is the same while sending and also receiving data, integrity is maintained. There are times when you are downloading a file, they give you the hash function of the file, so that if you download it and you compare in a zip file and the hash function is not the same, it means the data has been corrupted or has been intercepted in one way or the other. So that is one way of checking for data integrity. Authentication exchange. So this type of security mechanism also deals with identity to to be known in communication. So it can be achieved at the TCP/IP layer, where we have some sort of two-way handshake mechanism, which is used to ensure data is sent or not. Of course, before you can send, there should be some sort of acknowledgement between both parties, the recipient and also the sender and the recipient. So the sender sends an information to the recipient receives it and sends an acknowledgement to the sender. That is a two-way handshake. Information is sent to the receiver. The first handshake is the information being sent, and the receiver also sending acknowledgement of receipt of that information that the sender sent. So that is the two-way handshaking that we're talking about here. Now, the traffic pattern, sometimes also known as the bit stuffing, traffic pattern. So we have traffic, that is data on a network or packets. Pattern, you're adding things to it. Or bit stuffing, you stuff bits. The bits that you have, you stuff it with more information. So this kind of security mechanism is also used to add extra bits into data, which is being transmitted. So we add extra bits to it. And what it does is it helps data to be checked at the receiving end, and is achieved by even parity, and also odd parity. All right, so still on specific security mechanism, I talked about the eighth one, which was not represented in the diagram, which is the routing control. So we can use this one to choose either dynamic or by prearranging specific routes for data transmission. So for instance, let's think about the searches that we do online. If we're in Ghana and you are searching for something using Google, by the time you click on search, you are routed to google.com.gh instead of the main google.com, unless you specifically specify that you should go to google.com. So when we routed to google.com.gh, because we are in Ghana, it makes the search more effective and tailored to Ghana. But of course, we can get good information from outside. Yeah, so you are routed based on your location for best experience in search. And also, that's still on routing control. Communication systems may, on detection of persistent passive or active attack, wish to instruct the network service provider to establish a connection via a different route. So there are times you are trying to visit a site, and if you're trying to conduct a passive or active attack on it and it's being detected, you might be blocked and forced to use a different route to have access to such application. So similarly, data carrying certain security levels may also be forbidden by a security policy to pass through a certain network or links. So routing is more like you are from a network, you are going to another network, so you are moved to a different network. Your direction is changed to a different network. That is more of routing. And we have the last one, which is the notarization. So this is a security mechanism which is involved which involves the use of trusted party in communication. It acts as a mediator between the sender and the receiver so that if any chance of conflict occurs, this will be reduced. So the mediator most of the time keep records of the requests made by the sender to the receiver. Okay, so yes, let me pause here. I'll come back again. I think I have, hold on, I have a sorry about that. I had a call, so I had to receive it. Yes. All right. So the other security mechanism which is um, pervasive security mechanisms. So now let's talk about such security mechanisms. So these are not specific to any particular OSI security service or protocol layer that we've talked about in the previous slides. So the first one is the trusted functionality. So with that, the general concept of the trusted functionality can be used to either extend the scope or to establish the effectiveness of other security mechanisms. So any of such functionality that directly provides access to security mechanisms should be trustworthy. So these are other security mechanisms, which is pervasive security mechanism. So the trusted functionality is one of them. The second one is also security levels. So when we have system resources which may have security levels or labels associated with them, let's take an example as so an example, well, maybe to find ways to indicate the sensitivity level as an example. Most of the time, it is often necessary to convey the appropriate security level with data in transit. And the security level or the label may be additional data associated with the data transfer, or maybe implied by the use of a specific key to encipher data or encrypt data by the context of data such as the source address or route. So based on the security level, um, these are other security mechanisms that might be pervasive security mechanisms that could be used. You can also have the event detection. Sorry. So in this case, you have a security relevant event detection, which can be used to detect the apparent violation of the security. So the process of detecting all the events related to a network security. And for security audit trails, the security audit trails usually refers to an independent review and examination of the system records. So any activity that happens on the network. So when an individual log onto the system, when you took an exam on the VLE, when you did something on the VLE, when you clicked on assignments, when you submitted an assignment. All these are audit trails. When you clicked on the exams to even take it, the time that you took, you answered a question on the VLE, the time that you came back to the same question to change your answer is also, all these are recorded in securities in some of these systems. These are security audit trails. So the security audit trails refers to data collection and potentially used to facilitate security trails. So whenever there are issues, you can visit the audit trail of every individual and know what you did at which particular time during an activity like an exercise, an exams, the time you took the exam, the time you answered a particular question. All these things are being mapped and stored in what we call the security audit trails. So be mindful when you are lying, you are called to defend yourself in one way or the other, and you try to lie. If they should request for their audit trail of your activities in a system, the security audit trails will give vivid information about everything or all your activities within the system. So please be careful when you answer questions like that when you're called maybe by a committee or something. Yes. Yes, so for security recovery, it normally deals with requests from mechanisms such as event handling and also management functions. So, as the name says, security recovery, it deals with the request for mechanisms such as event handling and management functions and takes recovery action as a result of applying a set of rules. So, if we need to find ways to recover um, data that we've lost, the security recovery is able to apply some sort of rules to be able to retrieve all this. Now, we have what we call the network security model, which is being shown over here. So the model for the network security or network security model. So from what you see, the network security model, as you see over here, exhibits how the security service has been designed over the network to prevent opponents from causing threats to the confidentiality itself and also the authenticity of information that is being transmitted from the sender to the recipient through a network. So in this subsection, I'm briefly going to discuss the general network security model, which you see here, where we will study how the message are shared between the sender and the receiver securely over the network. And we will also discuss the network security model itself, the network access security model itself. This is the network security model, and we'll discuss briefly the network access security model itself, which is mainly designed to secure the system from unwanted access through the network. So let's take the first one, which is the network security model or the model for the network security. So a message is to be transferred from one party, which is the sender, to another across the internet. So for a message to be sent or received, there must be a sender, which is this case in this side, and a receiver or a recipient, which is this one. So both the sender and the receiver must be mutually agreeing to the sharing of message. That is the first thing that should come in mind. They should both agree to mutually, they should be ready to share or receive such information. So when that is done, the transmission of the message from the sender to the recipients will need some sort of medium to transmit the message, and in this case, the medium that we talk about is the internet service. This is the information channel that we have in here. So we have two parties who are principals in the transaction. They must cooperate for the exchange to take place. So there will be a logical information channel which will be established by defining the route through the internet from the source to the destination and by a cooperative use of communication protocols. So in this case, we'll be using TCP/IP to send information to these two principals. So this logical route is defined through the network, which is the internet, from sender to the recipient or the receiver, and using the communication protocol, both the sender and the recipient establish some sort of communication between them. The security aspect also comes into play when it is necessary or desirable to protect. So this security aspect, it comes into play when it is necessary or desirable to protect the information transmission from an opponent who may present a threat. Here's an opponent. We want to send something. So we need to consider a security aspect, because we might have an opponent here who may present a threat to confidentiality, authenticity, and integrity. So all these techniques for providing security have two main components. That is the security-related transformation on the information, and also some security information shared by the two principals. So in this example, it includes an encryption of the message. So we find a way the security information. For this particular example, it will include an encryption of the message which is scrambled, or which finds ways to scramble the message so that it is unreadable by the opponents here, and the addition of the codes based on the contents on the message, which can be used to verify the identity of the sender. Sorry. So we also have a key and security information that is given to the recipient. So for the security information shared by the two principals, it is hoped that this particular security information, which is the key, is unknown to the opponent. This is the key, is unknown to the opponent. So in this example, an encryption key is used in conjunction with the transformation to scramble the message which is being sent by the sender before the transmission is scrambled or deciphered or encrypt or decrypt by the receiver on the other hand of the communication channel. So this is how it looks like. So you can see that the general model shows that there are four basic tasks in designing a particular security service. So the main thing is, the first one is there are four main basic tasks that is involved whenever you are designing a particular security service. The first one is by designing an algorithm to perform the security-related transformation. You need to have some algorithm or pick an algorithm, and such algorithm should be such that the opponent cannot defeat its purpose. So we should take an algorithm that is secured enough, which makes it very difficult for the opponent to defeat that particular purpose. And secondly, we'll find a way to generate the secret information to be used with the algorithm, which is the key information, and that one is being shared with the recipient, and that is also not given to the opponent. And the third thing is we'll develop a method for distributing this and sharing of the secret information. You have to find a way to give the the secret information. If we are using this channel to send the secret information to the opponent, we can use a different channel to send the secret information so that the opponent will not have access to that particular the message that we are sending, that the message that we have decrypted and sent across. So if you are using internet for one, you can use text message for the other in terms of the secret information. And finally, we will find a way to specify a protocol which will be used by the two principals, which is the sender and also the receiver, that makes use of the secret algorithm and also the secret information to achieve a particular security service. So these are the four basic tasks that we have to deal with to be able to securely send information from the sender to the recipient without the opponent having access or eavesdropping on the information that we send. So this is the network access security model. So as you can see, whatever we've talked about over here. So when we talk of the network security model to secure your system, this can be shown in this figure as you see here. So there are virtually two ways to secure your system from attackers or adversary, of which the first is to introduce what we call the gateway function. So this is the gateway function. So introducing the gateway function means introducing either login IDs and password, which will keep away the unwanted access. So if you have an information system somewhere here that contains data of students or staff and the rest, you should first of all have what we call the gateway function, which is the login or the login page, which takes in the login IDs and passwords of people that are legitimate users of that particular information system. And of course, these legitimate users have the right access control to be able to access the right files and right data at any point in time. So in a case where the unwanted user gets access to the system, you can also have an unwanted user having access to the system. Then we would now fall back on the second way to secure our system by introducing the internal control. Now they are already in the system, so they are within the internal system. So we have to find ways to introduce an internal control which will detect the unwanted user trying to access the system by analyzing system activity. It could be a two-way authentication. You can add a two-way authentication for your gatekeeper function. But once maybe they're able to circumvent your system and have access to it, then we will fall back on the second way to secure it, which is the internal control, which by chance will be able to detect the unwanted user trying to access the system by analyzing system activity. So this particular, the second or the fallback control, which is the internal control, second way, the second method, we call such method as antivirus. So the second method we call as antivirus, which we install on our system to prevent the unwanted user from accessing your computer system through the internet. So if your system has whitelist some specific IP address, by saying whitelist, I mean to say your system have been able to detect some IP addresses. It's also only accessible by a specific IP address. Those ones are the whitelist IP address. So the second system we may call our antivirus, which we install on our system to prevent the unwanted access from accessing our computer through the internet. So only whitelisted excuse me, IP address will be able to have access to our system. So in general, to have a general model as illustrated over here, this will reflect a concern by protecting an information system from unwanted access. So if you have the opponent, be it human attacker and the rest, when you have an antivirus as a backup, you'll be able to block these adversaries from fully having access to the data that we have. That is the use of a software, which is the antivirus, to take care of the virus, the worms, and the intruder information, that intruder ways of having access to our system. So in this case, the hacker can be someone who will have no malign intent, but simply get satisfaction from breaking or entering a computer system. Or the intruder can also be somebody who is probably a disgruntled employee. He's so pissed with his employee did not really treat him right, and he resigned or sacked him. And if he's an IT person, he probably has a loophole in the system to always come in and also cause havoc on the system. Some of these disgruntled employees would wish to do damage, or a criminal who seeks to exploit computer assets for financial gain. You can find like the hackers the black hacker who wants to come into a system just to steal information or just to get money from an institution or organization. So now we've talked about various other threats for information systems, like the unwanted access and all these security services and all of that. And we should be mindful that there are various other threats to information system, unlike access. And some of these still exist. So the existence of hackers attempting to penetrate systems accessible over the network remains one of the major concerns of network administrators or cybersecurity analysts. So they always try to find ways, to mitigate attacks and all of those. So another threat is placement of some logic in computer system affecting various applications and also utility programs. I talked about loopholes, and people will put in some logic to come in. Others will also put some wrong logics just to cause a system to fail. So some of these inserted codes usually present two kinds of threats. And the first one is the information access threat, intercept, and also the service threats. So when we talk about the information access threats, what it does is it intercepts or modifies the data on behalf of users who should not have access to that data. And for the service threats, what it does is also find ways to exploit service flaw in computers to inhibit the use of legitimate users. So sometimes viruses and also worms are two major examples of software attacks, which is normally inserted into systems by means of disks or also across the network. So these are ways that you can have some of these service threats, incorporated or introduced into a system. There are security mechanisms that are needed to cope with some of these unwanted access fall into unwanted access to some of our system. So we need to find ways, to deal with some of these issues. We'll talk about them in subsequent chapters. We'll talk about cryptography and cryptanalysis and the rest. So I would end here, and this brings us to the end of our first chapter, which we talked about attacks on computers. We've been able to go through the introduction and the need for security approaches that are available, principles of security, types of security, the services and the mechanisms are available, and we've delved into the model for the security itself. So thank you very much for paying attention to this lecture. I'll meet you in the next one.